Today we're talking about derivatives of exponential and log functions. So we've done all of the trig, the inverse trig, and we've done chain rule, product rule, quotient rule, power rule. So just a few more to wrap up before we know all of the derivatives. So the first one is our favorite one. The derivative of e to the x is e to the x. It is the only function whose derivative is itself. It's a wonderful function. So we'll be using that one today. So the first example talks about the spread of a flu in a certain school modeled by this equation, where P of t is our total number of students infected t days after the flu was first noticed. Many of them may be well again by time t. So it's just saying, just because we get a big number, that's how many people are newly infected, not how many total. So letter A says estimate the initial number of students infected with the flu. If we're talking about an initial number, we're talking about at what time? So that would be at time 0. So we need to know what was the population at time 0. So we use that equation 100, 1 plus e to the 3 minus 0. So e to the third plus 1, and then 100 divided by that. And you should get approximately, you can put that in your calculator, 5 students. So now part B asks a question, how fast is the flu spreading? What I want you to do is make note of these types of questions. How fast? When you see that phrase, that's a rate. And when we start talking about rates, we know that implies a derivative. So we want to know the change in population with respect to time at time 3, because it said after 3 days. Now, I don't want to do the derivative of that function. That looks yucky. One thing that they want you to do is use those calculators. Use that n-deriv on your calculator to find numerical derivatives. So go ahead and take a second, find the derivative on your calculator. And I ended up getting approximately 25 students, I can spell, per day. And then part C says, when will the flu spread at its maximum rate, and what is this rate? That means we're looking for the maximum slope, the steepest slope, maximum rate. So you can graph the n-deriv function. So again, we practiced that in class a couple times. So go ahead and put that into y1, graph the n-deriv function and find the maximum. And we find that the maximum happens at time 3. And as we saw up here at time 3, the rate was 25 students per day. Should I just put studs per day? Wonderful. So then that leads us to another derivative definition. So we did e to the x, and the derivative of e to the x was e to the x. This one is a to the x for any constant a, like 2 to the x or 10 to the x. And so the derivative is a to the x natural log of a. Now just to point out that this actually worked for e as well, if we had e to the x, we would get e to the x natural log of e. And I'll put the derivative out here just to make sure we're... Sorry, I'm encroaching on the next example. But natural log of e is just 1, so that's why we get e to the x. Now this one, derivative of 12 to the x, is just 12 to the x natural log of 12. So in example 2, it says, at what point on the graph of the function 2 to the t minus 3 does the tangent line have a slope of 21? Tangent line. That means derivative. And we're talking about the slope equaling 21. So take a second, figure out what is the derivative of 2 to the t minus 3. And the derivative of 2 to the t is 2 to the t natural log of 2. And they want to know, where is that equal to 21? Now, what I would strongly encourage is to just graph this in y1, graph this in y2, and find the intersection. You could do this one out algebraically. You do not have to. So take a minute and solve that equation. So here it says, I solved this one using my calculator. I get 4.921. And the question asks, at what point on the graph does this occur? So it means I need an ordered pair for an answer. So we get 4.921, comma, and then plug that back into the original equation. So we get 2 to the 4.921, and then minus 3. So I get 27.295. And there's our answer. So you'll notice at the bottom of your page, you've got an exploration. That is going to be part of one of our labs in class. So you can hold off on doing this part. So go ahead and on to the next page. Our next derivative definition is natural log. And this one we've explored before, but the derivative of natural log is 1 over x. So when we get to example 3, the derivative of natural log of 5x squared minus 3x, we've got a chain rule, an inside function and an outside function. So go ahead and take a minute, put those two parts separated. So math magic, my inside function, my outside function, we do the derivative of both of those. The only thing left to do is combine those. So we get 10x minus 3 over u, and our u in this case was 5x squared minus 3x. Now you can take an x out and simplify that a little bit. You do not have to in the bottom. Last new derivative is, what if it's not a natural log, but it's a log base a of x? So we end up getting 1 over x natural log of a. Now just a reminder, natural log up here is the same thing as log base e. So just so you can see this worked, if it was natural log, 1 over x, natural log of e, again, natural log of e is 1, so that's why we just have 1 over x. So it's not a separate definition, it just actually works for both. So here it says, find the derivative of log base 4 of 7 to the x. So again, we have a chain rule. It's just harder to see, but we have an inside function and an outside function. So take a minute and separate those. So there's what we get, our inside and outside functions. So when I combine these terms, I get 7 to the x natural log of 7 over 4 natural log of u, and u was 7 to the x. So what I want you to notice is the 7 to the x's can cancel out. Oh, you know what? I made a mistake. Oops. Don't do that. You may not cancel those out. Hold on. Hopefully you caught my mistake before I did. It's 1 over u natural log of 4. I knew those 7 to the x's canceled out. And then these 7 to the x's cancel out. So go ahead and make that change if you copied down what I had just written. Hopefully you had it written correctly. So those 7 to the x's cancel out, and we're left with natural log of 7 over natural log of 4. For those of you who recognize change of base formula, this is the change of base. So this is equivalent to log base 4 of 7. So you do not have to recognize that. As long as you leave it here, you're totally fine.